I noticed that a lot of students struggled with short answer problem 4 on the exam, so I wanted to work through it and hopefully clear things up. The energy of the violet light emitted by a hydrogen atom is 4.85 times 10 to the minus 19th joules. Calculate the wavelength of this light in nanometers. Okay, our start point is that energy value right here. Our end point is lambda, wavelength, in nanometers specifically. Well, what do we know? You were given a few equations on your exam, including E equals h nu. So energy equals the Planck constant times the frequency of the light. We also know that frequency equals c over lambda, where c is the speed of light. We can algebraically combine these to say that E equals hc over lambda. We get that by just plugging in the c over lambda for nu, and we can rearrange that algebraically to get lambda, wavelength, all by itself, hc over E. Now, how many of these variables do we know? Well, our E value is that 4.85 times 10 to the minus 19th joules from the problem. C is the speed of light. It's a constant, 2.998 times 10 to the 8th meters per second. And H we said was Planck's constant, 6.626 times 10 to the minus 34th joule seconds. We know everything except lambda. We can now plug in our numbers. Lambda equals 6.626 times 10 to the minus 34th joule seconds times 2.998 times 10 to the 8th meters invert seconds. This is just a way to say, 1 over seconds. So this is meters per second. All of that is going to be over 4.85 times 10 to the minus 19th joules. Let's take a look at our units. The joules are going to cancel, and so are the seconds. So we're going to be left in meters as the units of our answer after we crunch our numbers. We crunch them down, round to sig figs, and we get 4.10 times 10 to the minus 7th meters. But remember, we wanted our answer in nanometers. We have to convert. 4.10 times 10 to the minus 7th meters. We know that 1 meter is 1 times 10 to the 9th nanometers. That's how many nanometers are in a meter. Whenever you're going from a larger unit to a smaller unit, you always multiply. If we do that, we get 410, the dot to denote this is 3 significant figures, nanometers. All right. I hope that clears things up. I will see you guys on Monday.